Hello children, welcome to another session of PYQ-JEE Advanced. Here I am with a question from Analytical Chemistry which had appeared in 2014 paper 2. So let us go through the question. An aqueous solution of metal ion M1 reacts separately with reagents Q and R in excess to give tetrahedral and square planar complexes respectively. An aqueous solution of another metal ion M2 always forms tetrahedral complexes with these reagents. Aqueous solution of M2 on reaction with reagent S gives white precipitate which dissolves in excess of S. The reactions are summarized in the scheme given below. You can just have a look at the scheme given here. The metal M1 with excess Q gives a tetrahedral complex, and the same metal M1 with excess R gives a square planar complex. And another metal M2 with these same reagents when treated gives only tetrahedral complexes. And this M2 on treatment with S, it first gives a white precipitate, and with excess of S, the precipitate dissolves. Identify these species M1, Q, R and S is the question. So to begin with, let us go through the options and go to the explanation. The first option respectively is given. So M1, Zn2 plus is given. Zinc ion, we know for zinc 30, Zn2 plus, the outermost configuration for zinc, the configuration is, outermost valence configuration is 4s2 3d10, and when it is zinc ion Zn2 plus, it is 4s0 and 3d10. So in 3d orbital, 4s is vacant now for Zn2 plus, and then it is left behind with 4p and 4d which are also vacant. Zn2 plus 3d10, this is the configuration. 3d10, d10 system, and it has to accommodate, it says this forms, M1 forms with Q a tetrahedral complex and with R a square planar complex, means tetra coordination is what talked about. 4 coordination. So had it been Zn2 plus, it can provide only S and P orbitals for hybridization. It can undergo sp3 hybridization, B, whoever be the ligand, because it is D10 configuration. It can provide only its 4s and 4p so that it can undergo sp3 hybridization for tetracoordination, giving rise to only tetrahedral complexes. Only tetrahedral complexes. If it is tetracoordinated, it should be tetrahedral complex, and that must be M2 can be Zn2 plus as per this explanation, because it says M2 with either with Q or R, it forms only tetrahedral complex. So Zn2 plus can be, M2 is a possibility. So let us go to the next option box, nickel 2 plus. Yes, for nickel 28, we know valential configuration is 4s2 3d8, and when it is nickel 2 plus, its configuration becomes D8 system. D8 system. Now 2 electrons from 4s is lost, and 4s, 4p and 4d are vacant for nickel 2 plus. So for nickel 2 plus, the configuration is D8 system. This is D8 system. 2 electrons in the first 3 orbitals, and then you have 2 unpaired electrons in the 4th and 5th orbital. D8 system. Now if nickel 2 plus experiences a strong ligand field, it is possible for the electrons to pair up against Hund's rule, and then one d orbital will be left vacant. So in presence of a strong ligand field, the electron from 5th orbital can pair up with the one with the 4th, and you can get a vacant d orbital in 3D. So in a strong ligand field, electrons are forced to pair up against Hund's rule so that D can contribute, 3D can contribute, and it can undergo DsP2 hybridization to accommodate 4 ligands. And if it is DsP2, the complex should be a square planar complex. So for nickel 2 plus, a square planar complex is possible if it is a strong ligand field. And in a weak ligand field, if the ligand field is weak, electrons won't pair up. So it will remain the same. In a weak ligand field, it will remain the same. Electrons cannot be forced to pair up. Thereby, you don't have contribution from 3D. So now the only possibility is 1 4s and 3 4p undergoing hybridization, resulting in sp3 hybridization. Tetrahedral geometry is a possibility. So M1 can be nickel 2 plus. M1 can be nickel 2 plus salt, whereas M2 can be Zn2 plus salt. So let us go through the reactions now. It says with the excess of Q, it forms tetrahedral. With the excess of Q, it forms tetrahedral. With the excess of Q, it forms tetrahedral is what is given. So let us see. So let us see here. Nickel 2 plus HCl is what is given. You are asked to find out M1, Q or S respectively. So if Q is HCl, excess HCl, it provides the ligand, chloride ligand, which is a weak ligand. So if it is in a weak ligand field, then sp3 tetrahedral is true. NiCl4 2 minus can be sp3 tetrahedral, true. So M1 can be nickel, Q can be HCl. Now let us see R. Our third option is KCN. So KCN, nickel 2 plus with the excess of KCN. KCN is going to provide cyanide ligand, which is a strong ligand. And in a strong ligand field, nickel 2 plus will undergo DsP2 square planar complex. Possible? So NiCN4 2 minus can be DsP2 square planar complex. Yes, possible. And coming to the last point, it says M2 on treatment with a reagent first gave a precipitate which got dissolved, and that reagent is S. Let us see what happens when M2, if M2 is Zn2 plus, when treated with, it is given KOH, in alkaline medium, first zinc hydroxide, which is sparingly soluble, will get precipitated. You will get a white precipitate of zinc hydroxide, to which when you add excess KOH in excess OH minus, zinc complexes with OH minus ligand, thereby it forms the complex ZnOH4 2 minus complex, which is water soluble aqueous. So it dissolves. First it gives a white precipitate which dissolves in excess of the same reagent. So the reagent S can be KOH is possible. So from these explanations, it's very clear that our correct option must be box. So let us go through this question once again. It says M1. Let us see who is M1 from the question. Let us go to the scheme once again. It says M1 with excess Q gives a tetrahedral complex, and with excess R gives a square planar complex. And as per our observation, M1 can be nickel 2 plus because nickel 2 plus D8 system, which can be in strong ligand field, the electrons can get paired up against Hund's rule of maximum multiplicity. Thereby, it can provide a vacant D. It can undergo DsP2 hybridization square planar complex in a strong ligand field, whereas in a weak ligand field, electrons won't pair up. So, sp3 tetrahedral. So, Q can be, if it is giving tetrahedral, Q must be somebody who is providing a weak field. HCl is possible, which will provide chloride, a weak ligand. And if the same is forming a square planar, it can be KCN because cyanide is a strong ligand. Coming to M2, whether it is HCl or KCN, if it is Zn2 plus, it can form only tetrahedral complex because it is Zn2 plus is D10 system. So, be it a strong ligand or weak ligand, it's going to give us only sp3 tetrahedral complex. So, M2 may be Zn2 plus. And if M2 is Zn2 plus, then in alkaline medium, first zinc hydroxide, water insoluble or sparingly soluble zinc hydroxide is precipitated, to which when you add excess KOH, it forms a soluble complex ZnOH4 2 minus, or you can also write it as K2 within square bracket ZnOH4. Thank you, children.